Good morning from my side. I'm Matthias Guertler. I'm a researcher at UTS and also co-program lead together with Glenda for program 3 of designing social technical robot systems. And I'm really glad to have this big group of people here today for this seminar series. Let me share my screen. So can you now see my screen? Okay, perfect. So the session today is around design principles and guidelines for health and safety at work with a focus on cobots. So before we start, I and my co-facilitators also would like to acknowledge the traditional owners of the land where the session is held, knowing that everyone is joining from different locations. At least this presentation was created at the land of the Gadigal people of the Eora Nation. And we would also like to pay respect to First Nations elders, past, present, and emerging, their knowledge, culture, and enduring insights, as well as to Aboriginal and Torres Strait Islanders people in this session. In terms of the agenda for today, it's basically the purpose or the intention is twofold. On the one hand, we like to share some insights of an associated project associated to the Australian Centre for Cobotics. But we also purposefully picked an interactive format, so we'll get a link in a second, to make it more engaging for you and of course for us. But we would also be keen, also to get your thoughts and feedback on the content we are presenting. So it's not just us giving a lecture to you. We really want to have a small discussion and see what you think, and if you agree with our findings or if you find them surprising or contradicting to what you have been experiencing in your own organization, in your group, or your work in general. I talked a lot about we, so it's myself, but we also have Laura and Leila as co-facilitators. But you will meet them especially in the second part of our seminar journey. So what do I mean by journey? So we have prepared a Miro board. And so instead of having a PowerPoint presentation, we basically have different slides put into our Miro boards. And what we do is we walk through, and you already can see some yellow and some blue boxes or shapes. And these indicate actually some interactive elements where we would keen to get your thoughts and ideas. And in the middle, we also have a break indicated by this blue arrow. So what I will do is, or maybe let me briefly talk about the project in general before I share the link with you. Otherwise, probably everyone is opening it and not listening to me anymore. So some context information to this presentation and also the insights. So the insights we are presenting today are part of a project here at UTS. It's with the Centre or New South Wales Centre for Work Health and Safety, and it's an associated project to the Australian Cobotics Centre. And it's, for example, closely aligned with program 3 around designing social technical robotic systems, but also, for example, with program 5, which focuses on human aspects of Cobalt system. The background why we did this project actually overlaps with the intention of the Australian Cobotics Centre. It's around the fact that we have a new generation of autonomous robots which work more closely with humans together, more closely than traditional Cobot systems, which were usually fenced off. And while this allows a multitude of different advantages, it also comes with specific challenges and issues, especially around work health and safety. So how do you make sure that the robot isn't injuring or even killing its human collaborators? And so the goal of this project was to analyze potential harms and risks around Cobot, work health and safety, but also mitigation strategies, principles for designing safe workplaces, and then turning this into a guideline which can be used by companies as well as universities, or maybe even in the future by regulators when they build regulations or standards on it. Okay, so before we start, let's do a little icebreaker exercise. Let me share this Miro board link with you. So everyone should get access to Miro using this link. And everyone should also have permission to edit and change things. So I would just ask you, please, not to change the slides we have prepared. It would be a little bit a challenge then to run through. But what I would like you to do is, first of all, pick one of the dots for the first question to indicate, have you worked with a Cobot before? And the second question is, somebody is already moving the slides. Cool. Just placing a dot on this graph to indicate, have you worked with a Cobot before, or is it something completely new? We thought about having a color coding: blue if you're from a company or industry, and orange if you're from a university or academia in general. If you're not sure, just choose a color which you identify most with. And the second question would be, how do you imagine a Cobot could help you or your business, or if you're from academia, maybe your job or your work in general? And with the post-its, just move them or copy paste them, and the font size is adjusting automatically. Okay, so looking at the picture, so far I can see two groups. One group, working almost with the cobots on a daily basis. So I assume especially the colleagues from the Arm Hub. But we also have another group, who has seen cobots so far, but hasn't worked with them. So it's really great to see, because I hope for the first group, maybe there are some interesting insights which can help you to, or some inspiration for your work with your cobots. And for the second group, I hope our insights can help you in your decision or planning of how to get a cobot and what to keep in mind. Okay, looking at the post-its, how are we going there? So how could cobots help you? Faster prototyping, precise bespoke fabrication of tasks, quicker production, better quality of production. But they could also be used for a range of things to assist humans in different tasks, can help lift, hold, weld, drill, make. Help with heavy tasks. Okay, cool. Looking at most of the arrows I can see, it's not moving so much. So I think we've reached kind of a level of saturation. So therefore, let me move on to the next slide. So you can follow me either by just looking at the shared screen or by just following the arrow to the next slide, which is called What is a Cobot? So before we start doing any exercises here, just let me briefly explain what is a Cobot, and especially what's a Cobot in comparison to a robot. So there are different frameworks how to characterize it. So this one uses the level of interaction or the mode of interaction. So you can see on the far right side kind of a traditional robot cell where you don't have any interaction between a robot and a human, or the only interaction happens, for example, if a human puts in some parts in the cell, then locks the door or locks the cell, steps out, and then the robot is working autonomously. But as soon as somebody enters the cell by opening a door or by crossing a light curtain, the whole robot stops and nothing is moving anymore. So it's a little bit indicated by this image on the upper right side. The next level is this framework called Coexistence. So you have a robot, but it's not fenced off anymore. But the work doesn't happen in parallel. So for example, a human worker places some parts on a table, and while he does it or she does it, the robot stops. And as soon as the worker steps out of the range of the robot then starts with the task it's intended to do, like, for example, indicated on the lower right side here. Then we have two levels of collaboration and cooperation, which often have kind of a fuzzy differentiation. So cooperation is, robot and human are working in a shared space. There might be a physical contact, but it doesn't have to be. It could be, for example, that the robot helps with assembly tasks and places a part on a building group, then moves away, and then the human worker is putting in the bolts, for example. And in a collaboration, the human and the cobot are really working hand in hand simultaneously, which can have different levels. So for example, it could really be like on the lower left side that a robot is assisting like a human would do it by handing over parts, holding things in place. For example, if you have a welding application, holding the parts and then the human welds. But it could also be that the cobot is assisting the human by, for example, taking the loads of a heavy object. So for example, taking the load of this polishing machine here, or if you think about a sandblasting cobot, it would take, for example, the sandblasting cannon and deal with all the reaction forces. So the human doesn't need to take all the load, and it really makes the job less strenuous and also a bit safer for the human. Okay, as I said, there are different frameworks on how to characterize a robot versus a cobot. We would be keen to get your ideas and thoughts about it. So again, I would invite you to grab a post-it you can find on the left side, and put it on a place where you think, yeah, this doesn't align with how you see it or what you would change. And also to make it maybe a bit more interactive, yeah, please, yeah, just unmute, start your video, and yeah, also basically, yeah, share also verbally what you think about this framework. And maybe I give you a couple of minutes, think through it. Okay, so looking at some of the first post-its. So one is, yeah, is collaboration common today, or does it mostly exist in a university lab? Maybe it's a good question for the group. Maybe making myself very popular now. John, what do you think, based on your experience from the Arm Hub?
What do I think in terms of what exactly? You mean in the definitions that we're seeing?
No, especially the question, yes, collaboration common today, or is it more something
oh no,
we
it's
can find in university?
Yeah, it's not common at all.
Okay.
Yeah, not at all.
Okay. But it's also kind of good to hear because yeah, it really stresses the relevance of the ACC.
That's right. Exactly.
Okay. But in general, what do you think about this differentiation? Sorry for putting you on the spot here.
Sorry, me again?
Yes.
Since
I have you.
I think it's useful. I think it's a useful differentiation. It's always hard to explain to people what the term means, and I've seen this kind of this differentiation around a fair bit now, and yeah, it seems reasonable. I think it's a good starting point, really.
Oh, cool.
Yeah, I'd support it. Okay, yeah.
Otherwise, since I'm German, I'm always inviting German style feedback. So for everyone, don't hold back. Okay, thank you. Ellen, Elle, here.
Hello. Sorry, I lost all my Zoom functions. I couldn't see them. They've just been off the screen, so I was hidden there for a bit. I think most of the demonstrations I've seen in Australia have been coexistence. And they are almost it's a level of coexistence which is so removed that it's almost like just a traditional automated robot, like with a non-interactive kind of connection between the operator, the human, and the robot itself. So it's almost as if the robot could still be in a cell but there is no cell, and there might be another safety barrier between it, whether it's a curtain, like a laser light curtain or something like that. So I think I have yet to see, there's probably one demonstration I saw in Melbourne, which was cooperation. And I don't think I've ever seen collaboration represented in Australia. And I'm racking my brains to think of collaboration that I've actually seen, which doesn't look like it's been a little bit staged. That's been used in the industry. I'd say that a lot of collaboration and cooperations. Yeah, lots of demos, and they would have all been academic or university prototypes. I don't think there's anything that's been industry proven yet.
Yeah, actually, to build off that point, we heard from a kind of a safety peripheral manufacturer, and they were saying that most people are interested in cobots pretty much as fenceless applications, because it saves so much space not having to have this physical fence around the cobot. So that was the allure for a lot of people, that their clients. So I find that quite interesting. But, you know, collaboration is really fancy, and, you know, like, it looks really cool. So of course, like, the demos are going to show that type of work rather than the more probably practical uses in coexistence and cooperation.
So what you're saying is they're using them because they're small and not dangerous.
They're small, and you don't need a physical fence around them for them to safely work with people or safely do their task. Yeah.
I think it's also the algorithmic side as well, right? It's not just about the robot being inherently safe. It's also being able to do something useful with the robot. I think the reason why a lot of these kind of cell type environments work well is because everything is very well known beforehand. Nothing really changes or moves around. Whereas when you're working with humans, you kind of have to adapt to that, which I think is perhaps another big thing gating collaborative robots at the moment. It's the algorithmic side of things as well.
Okay, thank you. Just kept thinking about it, but probably interesting discussion for another seminar, how to drive this a bit. But looking at the framework, I can see some questions concerning what's the difference between cooperation and coexistence. There is a slight difference. The coexistence, they're really, maybe the graphics we're using are not the best, but there's kind of a separation in space between the two of them. So you have one dedicated area where you can place parts and then the robot picks it. In a cooperation, it's really a shared space, and you're standing next to the robot, and the robot, or Cobot to some extent, would already bring some safety features like speed limitations and also force limitations or limiting. The other one. And an opportunity for the ACC is how to see how we can work with large robots, which would be typically placed in a cell. Because many companies already have experience with large industrial robots, and finding ways to make them safer to use in more diverse ways will be a good step forward, a step towards coexistent, perhaps. Yes, I find this idea really exciting, because it's not only aligns with the ABB project at Arm Hub, but also with the upcoming Cobot welding cell at UTS. That's exactly the question: how can we turn this traditional robot into something smart and collaborative? Wonderful. Maybe moving on to the next slide. I'm a bit cautious with time because I want to have enough time for Laura and Leila to talk about some of the more project-specific findings. Just a brief overview of 4 collaborative modes for cobot safety, which are often mentioned in literature. So the definition, at least by Villani et al., is that for a cobot, you need at least one of the 4 safety modes. So you either need to have a safety-rated monitored stop. So for example, if you enter the work sphere of a robot, which is potentially dangerous, the robot stops in order to avoid collisions. Or you have hand guiding, so you can move the robot around, for example, for teaching it, or in order to that the cobot can assist you with specific tasks. Or you can have a speed and separation monitoring. So for example, you could define specific work areas. So for example, a green area, and if nobody is in the green area, or somebody's in the green area, so far away from the cobot, it's moving full speed. But if you, for example, enter kind of a yellow area where it gets a little bit more dangerous, the robot or the cobot might slow down and only runs with reduced speed. Or, for example, if you enter a red area, the cobot might block the axis 1 to 3 and only moves the minor axis 4 to 6 in order to avoid any dangerous collision or injuries. And the 4th feature, which you can see in or find in many cobots like URs, the KUKA and so on, is a force and power limiting. So if, for example, the KUKA hits you, the cobot hits you, it recognizes it that it hits something and stops, but also by limiting the force, potential injuries are limited. Or for example, if you have the Sawyer with the springs in the joints, that, for example, is an additional safety feature. Moving on to the next slide, it's an important, or we found it's an important differentiation when we talked to different companies, especially ones who haven't used cobots or even robots before, is actually a differentiation or distinction between what's a cobot versus a cobot system versus a cobot workplace. Because often we found there's a misconception talking about a cobot. Everyone assumes it's a safe product because also the marketing is telling you it's a very safe product because it comes with one or more of the safety modes that just presented you. But actually the problem is that often the cobot just comes as a cobot arm. So it's really just the arm without any tool attached to it. So it's actually an incomplete system. So it might have some control and programming interface, so you can make it move, but actually it can't do anything, because for this it would need a tool or a so-called end effector, which could be a gripper, which could be a welding torch, it could be a mill or whatever. But basically this end effector is crucial in order to enable the cobot to do something useful, to perform a specific task in the context of a use case. But this also means you can have the safest cobot, but if you have the wrong tool, you can jeopardize all the safety features. So for example, the cobot might be force controlled, which might work well if you have a safety rated gripper attached to it. But if you replace it by a knife, the force limiting probably isn't of much use because the cobot will still stab you. So this means in order to have a safe cobot, you need to look at the cobot system and also the safety features, which are part of the system. And this also means, and here it becomes interesting to the point raised in the last interactive exercise, how can we turn industrial robots into cobots? Because by having this system perspective or system view, it allows us to either have a safe cobot, which already brings all the safety features, but it also allows us to take a normal robot, which lacks all the safety features, but it allows us to integrate the safety features into the system in order to make the system as a whole safe for a specific use case. So for example, it could mean that we have specific radar sensors, which allows us to track humans or objects in a cell, which allows us then to define specific safe work areas, like for example, a red, a yellow, and a green area, and so on. But yeah, the technical side is only one side of the medal. Since we're working with humans, we also need to look at the workplace as entirety. So this means we need to also consider how are humans interacting with the cobot, meaning what's the underlying work? So how are they interacting with it? Are they trained? Do they know how the cobot will behave? Do they know how to, for example, program it, how to check if the cobot is safe or somebody tampered with it? But also aspects like the workplace, how is it set up, or the underlying work process. So for example, if the cobot is always lifting parts above the head of a human, it's probably not the safest setup. Or for example, if the work process of the human and the work process of the cobot are always overlapping, you're basically creating a lot of opportunities for potential collisions and harms. Okay, before we have a brief break, I'm just curious to hear maybe some opinions or some thoughts about this setup or this differentiation between Cobot system, and Cobot workplace. How does this resonate with you? Does it align with your experience, or do you see some mismatches, and what would these be?
Matthias, just one, probably a small, I will say, okay, so you're talking about only arms, but I'm thinking, I mean, a lot of the work I've done is with mobile robots. So I think this could be extended with not only arms, but also mobile bases. And applies exactly the same.
Yeah, good point. That's actually also something we experienced in the project, was that, so far it seems to be very much driven by a manufacturing perspective. But
manufacturing also needs mobile bases. I mean, it could be simply by delivering things, or a mobile base with an arm, so which makes it much more interesting.
Yeah, no, I fully agree with you. What I tried to say, I guess, was that often Cobot is, or the pictures are driven by a Cobot arm thing. So yeah, we should really replace this icon and have also mobile platforms. Or for example, also what we saw was basically a waitress Cobot driving around the restaurant, delivering food. Cool.
Yeah, and more and more we can have a quadruped or a drone. Will be a Cobot as well.
Where do you feel like it would sit in this diagram? Does it still sit in the orange section, or would it sit between the workplace and the machine? Or
I think that, I mean, the robot, I will say the piece of equipment without sensors, yeah, that will sit in the same orange area, and then with sensors it will be a Cobot system, and if it's interacting with a human, it will be in the Cobot workspace. So I guess what I'm trying to say is I don't think there is a difference between an ARM and a mobile base, although there is, right? But in these definitions, I don't think there is any issue.
Thank you. Yeah, very important aspect. Any other thoughts?
Yep, I've got one, a quick one. What about if the arm is not a Cobot, but it's, you know, like a big ABB super dangerous robot, but you can use it in a way with it and turn everything into a Cobot workplace, and you could have a Cobot system, but the arm itself is not a Cobot.
Yeah, good point. That's yeah, what we try to, probably my explanation wasn't the best, sorry for this, but this framework would allow us to say we don't need to have all the safety features in our Cobot itself, but we can have it in the surrounding Cobot system by having external sensors like a radar system to track people, or maybe a voice control. So if the operator screams, the robot stops. Yeah.
Okay, good.
Hello. Look, I'm probably a bit of a ring in here. I probably don't come from a industrial, robotic background. I'm more of an general industry, and I found this link. But I guess I've got a strong background in workplace health and safety, and looking at good work design and what that means, and looking at the task, the environment, the equipment. And I'm not quite sure if this is where to raise the point, but just a consideration, it's just, and you've got the physicality part of it. And I think that and I'm very excited by what you're doing and love your approach. But the other part that we do it, besides the physical demands, we've got cognitive demands as well, looking at that and what that impacts on it, attentional demands, perception, pace of work, and all those other factors. I think it comes into this part of the conversation. We're maturing with what we understand to be workplace health and safety risk factors. It's not just one physical, it's not just one hazard, and the one hazard that we see quite a lot is saying, oh, look at being hit, that interactive, that physical hit. But there's other demands there that interact with it and that contribute to the risk of injury and the risk of performance and error for it. So I just wanted to raise that in that space, in the human factors part, and how it sits with that part. So thank you very much.
I thank you. It's a great comment, and I'm really excited to hear it because it links perfectly to what Leila will present in a second. Because yeah, we really analyze different risks and also found out, so far a key focus is on all these physical risks, and only we have only over the last couple of years there's a growing attention also to this. What does it mean from a social perspective or ethical perspective? But I will leave this to Leila. Just checking in with the group. So I had planned to do a brief break right now, just 5 minutes. Shall we have this break or shall we push through? Okay, no response. So I would say maybe let's have a quick break, 4 minutes until 11 o'clock. And then, we show you some of the insights which we put into a guideline. Okay.
Sounds good.
Okay, so is everyone back? Maybe wait another couple of seconds. Good. Yeah. So what we discussed so far was just to set the scene, to make sure we have a kind of a common understanding what is a Cobot and also what do we need to have a safe Cobot workplace. So the project itself, maybe some words to it. It's running for 12 months in collaboration with the ACC. And what we did here was that in the first step, we talked, so first we analyzed, did a systematic literature review, academic literature, but also gray and industry literature, and talked to different people from industry and academia in order to identify what's the current state of cobots, but also what are specific hazards and risks in terms of work health and safety. Based on this, we also talked with another group of industry people and academic people what are specific measures in order to make a workplace safe? And based on this, we then developed a guideline. So basically, the guidelines will help us to turn all our insights we have developed and found so far into something which can later on be used in operational sense by companies, but also by academics. And the guideline itself consists of different parts. So first of all, we have kind of an introduction into the guidelines. Then we have a socio-technical workplace safety checklist, which allows users to assess if a Cobot equipment is safe, but also to assess a specific workplace from an organizational as well as from a human perspective. This links to a risk assessment template and form we have developed, but also some guidelines which are a bit more open. So the first ones are more analytical, they allow you to assess something, and the other two parts are more design oriented, so a bit more open, meaning that they support organizations in designing safe human Cobot interaction, as well as planning workplace roles. So which stakeholders are involved, what are their responsibilities, and what do they need to do. But also how to set up a workplace in a safe way. Since time is limited, we can't present you with all our insights, so we picked some specific ones which we thought would be most interesting for you today. But if you want to learn more already, the invitation, just to get in contact with us, we're happy to discuss all the other insights. With this, I hand over to Leila, who will talk about work health and safety harms and risks we identified.
Thank you, Matthias. As Matthias was saying before, we did a blend of a literature review and an interview study. And through the literature study, we kind of identified three main areas of harms that can occur in workplaces. So physical, psychological, and ethical. And then there was kind of a blend through the interview and the literature study to find specific risks and harms that can occur specifically around cobots. So this isn't general workplace risks and harms. This is specific to the Cobot system or the Cobot workplace. So from the top, the main hazard that we identified was hazardous collisions. So that's when the robot end effector or the arm or the workpiece itself hits into a human. That can be, it's quite a big umbrella term in itself, but it captures all types of collisions. The second one is the loss of movement control. So that's when the Cobot moves in an unexpected way, which can result in hazardous collisions, but can also damage the workplace itself and cause other risks. Pinch points is a big one, especially for non-conventional cobots. So machines that are being used not intentionally, they haven't been designed for collaboration in mind. So a lot of the smaller cobot models will have kind of soft edges and make sure that all pinch points are covered, but it's always important to consider that. Debris caused by the task at hand and its impact on any humans working in the same space. Cybersecurity was an interesting one that popped up. There has been some incidences of sabotage, and cybersecurity is an easy way. Well, one of the ways that machines can be sabotaged, and that can cause any of those other physical risks, and a lack of focus. within the psychological harms and risks, it was mostly looking at the mental strain. That was kind of the big umbrella impact. As you were saying before, Donna, you know, when we're forgetting that like cobots work with humans and that humans are fallible and we get tired and we lose focus. And so it's important to be aware of that. Interaction mechanisms are not intuitive and can frustrate people, and that can make their sense, it can make them less likely to accept or use the cobot. And there's a lack of trust that the cobot either will take someone's, that the user doesn't feel safe working alongside a cobot, especially if it's moving quickly. Within the ethical, we're kind of looking at the larger social impacts of a cobot coming into a workplace. This wasn't, the psychological and ethical sides were not really, they aren't really a key focus for a lot of the literature and a lot of the data that we were finding. But I think as cobots become more and more popular, it'll be important for us to look at these. So whether people are feel as though their sense of job security is still intact, whether they accept the cobot in the workplace, they find value, and that their agency as workers is still maintained. That was a really important one. And something that is not commonly reported is the lack of consent provided for data collection. So a lot of the cobots that we saw had, you know, they had camera setups and they were constantly monitoring workers. And so there wasn't much consideration towards, you know, the impact of being monitored all the time, and that your work as a worker is constantly being supervised and recorded, kind of that impact on that. So those are our general risks and harms. I was just wondering whether those categories make sense, if there's anything that you feel, anything that was surprising in that list, and if we're missing anything.
Probably, hello again. I guess I work for health and safety regulators, so I'm coming from that perspective as well, and looking at the terms, and I know that this was a literature review and what the terms that are used by general, you know, by industry versus what we know them as in those terms. And for part of it, yes, physical, excuse me, I've just still recovering from COVID, but the physical factors and speed of movement, etc. That's also the pace of work. The physical demands relates to the physical, and the psychological. I just probably it is a very broad church for that at the moment that is being used in psychological harm versus psychological health, and looking at the, I guess, psychological work demands, and that probably goes to that cognitive work demands is probably a term that we would probably relate more to, just to specify that part about what is the contribution between undertaking this task as it is versus the other elements of work for that part. So that's probably a suggestion for that part. The other part to it is that in the harms part, we see quite often that the operational side is the focus for it, but also we do the cleaning and the maintenance. What if something goes wrong with this task? What's required in doing that, and where is the requirements for that as well? So if and I wonder if that's a question is, I wonder if that's come up through the you know, your interviews or the literature search to talk about that part. So, you know, there are the elements that cause grief for workplaces.
Yeah, definitely. We do consider the Cobot life cycle. So there's, the planning, the programming of the Cobot, and the setting up, the installation, the operation and use phase, and then also maintenance and adjustments. So we have considered it, but I don't know if we've considered it very strongly in the harms and risks present. So yeah, maybe it would be helpful to map these harms to the phases that we have or something.
Yeah. Also, if I understand you correctly, there's also this double effect. So in terms of cleaning and maintenance, it could directly cause harm to the people, but it might also have an indirect effect. So for example, if while you're cleaning it, you might damage a sensor, which might have a work health and safety effect in the afterwards, because the Cobot can't detect you anymore.
Yeah, no, that's good points. Yeah. Good points.
Sorry, just one more question on that. Would you suggest that we reframe psychological and ethical harms into the cognitive work demands? Is that what you were saying, Donna?
I think it should be, if you can consider that. I'll have a bit more of a think about it, considering what you do, if you don't mind, and speak to some colleagues about it. But I think that I know what direction you're heading and where and what you're trying to cover. And I guess it's the balance sometimes what academic research terms are versus what we might use, particularly in Australia, to share that with industry is probably the gap I've noticed in when I look at literature and versus what we do as industry practice. So I'll take this as a screenshot of that and then pass it through have a chat to some colleagues as well. And if that's okay to get back to you.
Yeah, of course.
Thank you very much.
This would be great, because we are aware that we come from academic perspective, but really want to make sure that it's useful.
Yeah.
Companies and organizations.
Yeah, but this is the genesis of all the work. So I think it's brilliant for it, and very excited which direction it's going to.
Thank you.
Thank you.
Does anyone else have any comments on that table? Otherwise, might move on to the next point. If you have any comments, just feel free to leave. Oh, just feel free to leave a post-it note there. So that was, we did 2 reports, and the first report was examining the risks and harms that are present. And then the second report, we actually looked at safety measures that kind of help to mitigate some of those risks and harms. And distilling all of those 2 sections together, we came up with 5 principles that help workplaces design safe Cobot workplaces. And I'll quickly just go through them. So the first principle is to understand the features of your Cobot and the safety features that support the Cobot system. The second point is to maintain a human focus. The third is to align Cobot tools, workspace, and workflow. So make sure that every element is speaking to one another. The fourth is ensure security and protection. So that relates to preventing tampering in whatever way. So, it can be quite, malicious and in that sabotaging sense, but it can also be, a worker accidentally messing the code, trying to figure out how to stop the Cobot or whatever. So having those levels of authorization. And then the last one is to support the ease of use. So to try and make it as accessible and usable as possible, especially considering, especially for workplaces where operators may not necessarily, this might be their first time working with a robot in general. So those are our principles. just wondering if anyone has, yeah, do they make sense? Are we missing anything? Do they apply to any use cases that you've seen?
Maybe just 2 words concerning the principles. So you can see they're really phrased in a very abstract and general way. This was done on purpose because they should apply to entire life cycle of a cobot, from the planning over the installation, commissioning, use up to the decommissioning. And of course, in each of the phases, you would then specify them in more detail. So for example, having specific measures, for example, concerning the turbo type or work cell design or simulation and so on. But yeah, these are really some overarching guiding principles. Sorry, back to you.
Yeah, if you'd like, you can put a comment down. I'll give a few minutes for everyone to do that. Or you can, yeah, just unmute yourself and just speak. We'll write the notes for you.
It feels a bit like a lecture.
Yeah.
So putting people on the spot. Dan, what do you think?
Yeah, very, very, very interesting. I'm still kind of digesting, trying to get my head around it. I think my comment specifically with the last slide is around the ethics around data collection. And I think it's interesting because, you know, I think there's various levels of what data may or may not be collected. And specifically because I not only do as, you know, as researchers, we want to understand academic industry relations, but also at the organizational level, there'll be levels of optimization, but then also from a broader work health and safety level, I'm sure that we want to be learnings and insights there. So I think there's an interesting balance between the data of interactions and how that relates to incidences and the levels of incidences that may or may not occur. So that was just where what I was really thinking. Maybe we could go, I think in the framework, maybe it's an opportunity to go a little bit deeper in that, but that was just my general thoughts.
It's quite interesting. We didn't really hear much on it, and it's definitely, I think, an emerging field within like cobotics and workplace safety. Yeah, I'm not sure if, I don't know if we came across any frameworks or anything to support that.
Yeah, it may not be, I mean, you know, collaboration being a very new thing, it'll be more interesting with what, you know, it's also about safeguarding for the future. So I'm sure there'll be industrial bodies that will want to learn and see the data. So the same way that, you know, state governments collect data on, you know, road safety, injuries and workplace injuries and insurances, there's definitely a case for, you know, cross-organizational data points to actually tell us where, you know, common themes, common issues that happen potentially with cobots in the workplace as well. So I think it's a really interesting area.
I mean, I think I remember we spoke to a manufacturer, a cobot manufacturer, and they were talking about how this is actually we spoke to a few people that were talking about how data was their actually a gold mine for them. It was something that they could potentially learn, derive a lot of value out of their products. And yeah, I guess there wasn't much awareness, at least from the people we spoke, on how much data is being collected from those manufacturers and what who has access to that information and what they're using it for. Yeah.
Yeah, I mean, you know, data intelligence and data science is a whole separate field, but yeah, it's just really diverse. So yeah, everything from optimization of the workplace through to health and safety, I think is, you know, kind of worthy of probably broadening out, I would think.
Hi. To contribute to the conversation about data collection, I know that for workers' compensation data collection, it is a bit limited. And I'm not quite a guarantee that that's going to be a rich source of data for you because of how the fields are put in place when people put in workers' compensation claims or incidents. And working with other smaller industry sectors, particularly as a niche area like this relative to the broader safety, I wonder if working with the manufacturers, considering there's a small number, whether they can help with like post-implementation, post-use surveys that are specific for it, and they could have tailored questions related to the key areas that you're looking for workplace health and safety. And sometimes it can be from the surveys, maybe, you know, 1 month, 3 months, 12 months after the implementation of these pieces of equipment into their workplace about what they're finding for that part, because sometimes it may be through that life cycle that they'll come and pick up some more issues, that more use, excuse me, putting the cobotics in and, you know, maybe expanding their use of it and, you know, and what their learnings are for that. I'm a keen fan for that part because you've got a very niche area. The manufacturers will be, and suppliers, they've got a duty and obligation under the workplace health and safety as well, but also that they would have a vested business interest in finding out what's better and works well for them. So perhaps that's another way of keeping the network close, particularly in this. It's a booming area, and to be at the front of this is a great potential. You know, it's all sharing. No one's going to be perfect with it, and I guess that is it's going to be a safe environment for people to do that, to follow through, so that we can be, I guess, in that evolution, because to be successful in having it, you know, for user experience as well as user safety as well, I guess, meaning that it's going to be a more successful product.
That's actually a really good idea. Thank you.
Then we might even use it for the Open Innovation Network.
100%. I'll add my 20 cents as well. That I did. I've done 2 site visits or factory visits recently. One of them, it was interesting to note that they were very concerned with human focus, as in their existing employees having prior knowledge or having kind of an ease of introduction to cobotics before Cobot would be introduced to their factory. And this was a factory that already, they do use robots, a lot of automated robots, and they're very agile in the way that they kind of implement technology. But they were still very concerned about just bringing cobots into the factory without any of their employees having any previous knowledge about what a cobot is or what a cobotic system is and how it was going to impact their work. So they made a very strong point repeatedly about, we really want our employees to know about these cobots, what they are capable of doing, and how realistically their jobs are not, they're not under pressure to lose their jobs or have their job changed dramatically but this is something that will actually help their work, their day-to-day work. And interesting to note that at both that factory and another factory, they both had huge amounts of data, and they just didn't know really what to do with it. They said, we capture this data on an hourly, almost minute by minute basis, so we know exactly how much we're producing of what type of item that we are producing. And we don't really know what to do with this data, though. We don't really know how to visualize it, how to compare it to previous data, apart from just, traditionally looking at it from a spreadsheet point of view of just like units per hour or units per day. That's the only way. But they said that they know that in that data, there's a lot more that they can get out of it. And they were kind of making a lot of requests at that point of saying, this is something that a data scientist could definitely help us with, and we know nothing about it. And it was almost like kind of like a plea for help in a way, in regards. But they knew straight away. They said this is something that could help us throughout every level of our organization, from a safety point of view to collaboration with new technology, through the actual output, through the money that we could make from this. We could actually become a lot more efficient by analyzing this data across time. As Donna was saying, like kind of as from an academic point of view, an action study before the introduction of technology or a cobot, and then immediately afterwards, and then 3 months, 6 months, 1 year later. I think that's very important, and I think that's coming up a lot in the literature I'm reading, is the importance to see those changes in cobotics. It's not enough to just introduce a cobotic system, do an immediate report on what workflow. You need to come back and revisit it at another point and be like, was it a success? Yes or no?
Yeah, that was actually something that came up in the second report we did. The idea of the way that you help mitigate some of those like ethical risks is by supporting work agency, training, and having constant consultation and evaluation with your staff to make sure that the integration and adoption of the cobot is as smooth as possible, and that they feel as though they have some control or some impact on the process of adoption. And yeah, we heard from people that it's a iterative cycle. You talk to a staff member about how they're feeling, and then try to implement some interventions to try and help mitigate some of those feelings, and then you consistently just reevaluate. So yeah, thank you both for that. I might let Laura lead now, because I've taken up quite a lot of the time.
Okay, thank you, Leila. Okay, so the next couple of slides and activities relate to the 5th document that we were talking about. So as Matthias was saying, in the guidelines, we have more a part that is related to a situation where you have a system in place and you need to do a risk assessment by considering socio-technical aspects. And then one part is more creative and design oriented, and that's what we're going to focus on now. So these 2 slides relate to this document in particular. The way we thought about this document is to be high level enough so that it's applicable to all types of tasks and use cases of a cobot. But also the idea is that it clarifies expectations and roles and responsibilities throughout the life cycle. So basically, we're mapping the stakeholders and their roles and responsibilities through with the stages of the life cycle. The idea is, so this is in the first part of the document, because we realize that in big companies, for example, you have clear roles and multiple roles that have clear tasks and so on. Whereas, for example, in SMEs, there are the ones that maybe may use cobots a little bit more. Those roles blend. We want to clarify first what we consider as, for example, integrator, operator, managers, and administrative staff. Based on that, Then we're gonna define responsibilities for each stakeholder throughout the life cycle. And then we'll show you some examples. But the first part relates only to what we consider as. So what we'd like to know is if you think those categories are comprehensive enough, if you think there should be some extra ones that we need to consider, or this is a good overview. So the ones that are shown here are the two types of manufacturers, so the Cobot manufacturers, and this distinction is based on the graphic that Matthias showed you earlier. So the Cobot manufacturer basically will provide you only the arm, the cobotic arm, whereas third-party manufacturers are the ones that manufacture all the other equipment and the factors and so on. And then we had distributors and suppliers, and often companies may deal with them a lot more than they would do with the manufacturers. Let's say they will buy from a supplier or distributor, and whenever they have issues, they will go back to them. And then we have integrators. So under integrators, we included a whole list of tasks because this is quite broad. So for example, in a small company, the integrator could be someone that has enough technical knowledge to combine the Cobot system together, but also try to do the programming of the tasks and so on. So we included several tasks, and then I'll show you the reason why it's highlighted is because in the following part, I will show you the responsibilities for integrators, just to give you the example of one of the stakeholders. And we included a fair few tasks, including troubleshooting and maintenance, integration, configuring hardware and software. And then there's operators. They are the ones that directly and physically interact with the Cobot and perform tasks and supervise the Cobot on a daily basis. Then there's passive users that interact with the Cobot but don't control and supervise the actual system, and that's why they sit in the category that is not, like in the right column where it says they're not responsible for controlling and supervising tasks. And then co-workers and visitors are the people that might walk past or unintentionally maybe interact with the Cobot. So the people that could be in the shared workspace. And finally, there's managers and administrative staff that take care of all the decision making at a high level of the company. So if you want to have a read through and maybe write your comments or ideas in the post-its, just there's also a note at the bottom saying that integrators, because it's a broad role, it could be a third-party company, it could be someone within the company that is purchasing the Cobot, or it could be part of the distributors and suppliers, for example. So if you have comments that you want to share directly or write down ideas, yeah, I'll just give you maybe a few minutes. Okay, I see a post-it there related to data and optimization. Do you mean data, like data collection, how the data collection is managed and potentially the data is used to optimize the tasks?
Yeah, 100%. So you probably see a common theme in my sort of train of thought here. Commonly, integrators are responsible for implementation, all the tasks you put in as well. But I think it's an ongoing task, given that they're more services rather than product based, for optimization. So, you know, any manager also wants to see, or any CFO wants to sign off more cobots. They want to see data in place. So I just think, again, that data is an important part of the integrator's role. And, you know, so it's sort of embedded inside probably the last point, implementation, support, troubleshooting, maintenance, those kind of things. But again, just sort of trying to call out the importance of data and the interplay with data and interaction, tracking and measurement.
Yeah, totally. Yeah, that's a good point. Do you think that even if integrators are the ones that are gonna kind of figure out how to collect the data, eventually will be the management that figures a way to make that data valuable? Or is totally on the integrator?
I think it's hard to say. I mean, I think the organization will want to own the data and keep the data in-house primarily. There will be integrators out there who are also trying to do, you know, like have a cross dashboard view, but it will also be the manufacturer of the Cobot itself. So probably won't sit with the integrator unless they've got a business model that's really trying to do that. The data will primarily be between the organization and the Cobot itself.
Yeah.
Does that make sense?
Yeah, totally. Yeah, that was my feeling, but yeah, it kind of blends over a lot.
Yeah, it would be just the case of the integrator, you know, making sure that it's producing enough data and data points, and that their whatever presentation layer is there is going to be valuable for the organization, whether it's now, you know, or in Alan's point, you know, if they get producing too much data, at least they've got something that, you know, later down the track they can optimize through a data scientist or some AI or something like that.
Yeah, totally. Yeah, thank you. There's a few more operators. Yeah. So the management put in place effective maintenance program. That's, yeah, totally something that we can add. Because, yeah, surely the maintenance policies are driven by the management. And then operator supervisors to report results and incidents. Yeah, that's also a good one. Okay, I'd say we can move on to the next part. So, okay, now we see all these categories and stages mapped together. So we have at the top, we have all the stakeholders, and that's why we had that table before, because as I said, depending on the type of company people are in, they might have different job titles, different categories, and so on. So first of all, we want to allow them to recognize themselves into one of the roles. And then we look at all the life cycle phases, and we define high-level principles that aim to reduce ambiguity and clarify expectations to make sure that not only we cover the standards, but also we want to include social, psychological, and ethical aspects. and we want to make sure that nothing is left behind. So this document in particular also refers to other parts of the guidelines, but also refers to the standards. Like, it's not something that is going to replace the standards, but gives high-level guidance and reduces ambiguity in a way. So the reason why I highlighted integrator is because there's, like, we won't have time to go through all the stakeholders, but that's one of those that has quite a lot of influence throughout the life cycle. And two of the phases that we can look at today could be installation and commissioning, and use phase and operation. Also, these principles all reflect the general principles that Leila's covered earlier. So keeping a human focus, security and protection, and so on. But they are specific to the stages. So for example, we use the RESI framework. So we define who's responsible for the task. Sometimes more than one person is responsible, also because, again, we want to cover different types of companies. So sometimes management and integrators are both responsible, for example. Some stakeholders are accountable, so in charge of delegating work. Some are consulted and some others are simply informed. So if we look at installation and commissioning, for example, and we look at responsibilities of integrators through that phase, we see that we want integrators to consult with their workers, to support workers' agency, but also to gather feedback from their experience. And in that sense, they encourage, like, integrators should encourage operators to actively provide feedback. And then, oh, sorry, just a quick note, all these principles, like, this document is it's like around 20 pages. So all these principles would have a full description in the document. So I'm just gonna give you a brief summary. And then back to the responsibility of integrators for installation and commissioning, address workspace specific risks and safety boundaries. So as I said, we want it to be applicable to all use cases. So this means that you need to assess the risks to this task that you're trying to set up, and allow the operation only within strict boundaries, even if they're not physical boundaries, and add any additional equipment in case the Cobot system is not naturally safe. Then integrators are also responsible to conduct the testing and use various procedures, not only simulation and actual physical testing, but possibly a blend of those. In cases some of the components of the system are not naturally fail-safe, so that means that they cannot naturally revert to a safe condition in case of a breakdown. We want the integrators to include additional equipment to allow the safe conditions. And then there's also an educational part about educating the company about cybersecurity and the risks that can present, and also to make sure that the Cobot system has clear communication channels to prevent any psychological stress related to the fact that operators might not know what the Cobot is doing or how to communicate tasks to the Cobots and so on. So this was related to installation and commissioning. If you see in the use phase, the responsibility of integrators are much less. So the only one would be allowing the use of Cobot only within recommended settings. But most of the responsibilities in that phase, for example, will shift to the operators that, for example, should monitor the workspace, so should secure the system to prevent any unauthorized people to enter the cell and so on. So the idea of having all these stages and all these stakeholders is also to show how the responsibilities shift from one to the other along the life cycle. So product development and manufacturing obviously will have manufacturers a lot more involved. And then as the workspace is planned and set up, integrators and managers become very important, but then use space and maintenance becomes more a responsibility of operators and managers again. So if you want to have a look and then maybe take your time to read it through and share your opinions, if you think this is like a good framework, is intuitive enough, if it's too high level, and so on.
Probably everyone is overwhelmed now. Well, maybe also looking at the remaining time, kind of a general question. Do you think having such a table, which is really outlining in quite a level of detail roles and responsibilities, do you think this is something which can really be helpful later on when you plan and manage the safety of a workplace, or is it already too detailed, or is it not detailed enough?
I mean, it's a good checklist, basically. Very valuable.
I was thinking this could lend itself quite well to being like a visiting website where you could go there and maybe answer questions, and it will kind of step you through it. It's because it's very comprehensive, almost a little overwhelming, I'd say. But it is it's very thorough. So I think for anybody just visiting, not really knowing anything about, they know that they want a Cobot, but don't know how they want to implement it. Maybe this would be a good way of saying, like, well, this will be the responsibilities that you will be facing at some point, and it's like kind of ticking off, like, who are you? I'm a manufacturer, but this is what you will need to be doing as part of your responsibilities or your accountability.
I agree that it's really good to have something like that, this guidance for it, because it's a huge learning curve for many people starting off in this area, and you're sharing, you know, your knowledge into that, and then for that to grow for that part. But and people who are going to be you know, the integrators in here, it'll be clear for them what they need to do, and also help with that understanding of other people in that they're going to work with, about what their role is and why they're doing it, rather than saying, oh, why are you spending so long doing this? Can't we get it done in you know, such a short time frame, when you know that, you know, these are the steps that are required for that communication for it, and it's going to be, and there I guess concurrent obligations of other people, not just the person in this role, but the people that they have to interact with at the workplace, and how it makes it work for them.
Yeah, I agree. Yeah, it makes perfect sense, or helps with your own task when you understand who else is involved, you understand the big picture. Okay, but it's good to hear because yeah, it's one of the challenges developing this guidelines, really to find the right level of detail, because we want to be detailed enough that we can provide support, but on the other hand, we also want to be abstract enough that it's really applicable to a wide range of industries. And sorry, I'm always mentioning things we are not showing today. Yeah, for example, we also have another checklist where you can assess the safety of a Cobot and a Cobot system. But here, for example, we are then also just flagging what you need to consider, but then also providing references to more detailed documents like standards, which hold all the details which you need to do a more detailed assessment. But the goal is really to provide kind of a easily accessible document for people who haven't worked with a Cobot before, or people who have worked with Cobots for a couple of years, but might look for new inspirations or to check if there were any updates or advancements.
I mean, also, it seems to me like a great framework and checklist for developing training programs, right? If you can tick all these boxes for a training program, that's fabulous.
Yeah. That's actually also a good point. So looking at the time, I probably skipped the last slide, which was a kind of a feedback slide anyway. It's also important to mention. So this project will end in a month's time. So at the moment we are wrapping everything up and also working on publications and everything. But as I mentioned, this project isn't a standalone project. It's really an associated project to the ACC. So all the contents will also live further in the ACC, and hopefully will also be enhanced and further improved. And one of the key visions we had is really to turn this into kind of a training module, which we could use in the ACC, but which could also be used for university teaching, training, and so on. But also maybe something like a guideline which we could give to new company partners of the ACC, but also make it available to the broad public as well. Okay. We have 5 minutes left. Are there any thoughts or any general feedback to the guidelines or to the content we showed you? As I said, the purpose was really to show you something, but also to get your thoughts and your feedback to make sure that we are on the right track.
I think this is great. This is really kind of rewarding, and the more I see the different slides, I think this really actually could be an online, like a portal, like a toolkit that you could implement each of these as a separate little web page, and you can just kind of do it in layman's terms for people visiting. And I think this would be really good to market this really well also. And this could easily be something that's part of the ACC. Hint, John.
Yep, on the website.
Yeah, on the
sure.
website. Yeah. Do you want a Cobot? How can I use a Cobot?
Exactly.
Will it make my life easier? And this, yes.
It's a very, very good idea.
With some snappy infographics as well.
Yeah. Maybe some little videos explaining various aspects.
Do I understand it correctly? I have 2 volunteers.
It's been a while since I've used HTML, so probably moved on since then.
I'm really glad to hear.
No, this is valuable work, so thank you very much, and I'm really quite excited by it and the guidelines for it, because going around to different workplaces, you can see where the future of these awful tasks that are causing injuries and and disability can be used. Excuse me. So no, this is great, valuable work for that part. So thank you.
Yeah, thank you. It's really great feedback, and it's always good to hear that what we did it makes sense. Okay, looking at the time, if there are any other questions, or if you want to see more details of the guidelines, as I said, we are working on the publications, but if you want to hear more in the meantime, just get in contact with me. We're happy to share and discuss. Otherwise, I would say thanks a lot for attending the session, working with us, and I really enjoyed it. And I'm looking forward to the next seminar.